The greatest common factor, or GCF, of two numbers is the greatest number that can be divided by both numbers. Just like with LCM, you can find the GCF with a variety of different methods, including making a list, using prime factorization, or using the slide method. So let's look at making a list for 24 and 40. I'm going to start with 24. And when I'm looking for the factors, I'm looking for what numbers are evenly divisible by 24. So 24 is always divisible by 1. And when I'm looking for my list, or when I'm writing my list, I also want to find what is the other factor. So if 24 is divisible by 1, it's also divisible by 24, because 1 times 24 gives me 24. Now my next number would be 2. I know that 24 is an even number, so it's divisible by 2. And 2 times what gives me 24? Well, I know that 2 times 12 gives me 24, so 12 is also a factor. Now my next number would be 3. 24 is divisible by 3, and 3 times 8 gives me 24, so 8 is also a factor. My next number would be 4, and 4 is a factor of 24, and 4 times 6 gives me 24, so 6 is also a factor. The number that comes after 4 is 5, but 5 is not a factor of 24. Next is 6, but if you've noticed, I've already written 6, so once I get to a number that I've already written, then I have my full list of factors of 24. Now let's do the same thing with 40. Just like 24, every number has a factor of 1, and 1 times 40 is going to give me 40. Now let's move on and look at 2. 40 is an even number, so it's divisible by 2, and 2 times 20 gives me 40, so 20 is also a factor. 3 would be my next number, but 40 cannot be divided by 3, so it's not a factor of 40. 4 is my next number, and 40 can be divided by 4. If I do 4 times 10, I will get 40, so 4 and 10 are factors of 40. Next is 5, and I can do 40 divided by 5. When I do that, I get 8. Now I'm going to look at my other numbers. 6, but 6 cannot be divided into 40. And then also 7, but again, 40 cannot be divided by 7. So the next number is 8, and if you notice, I already have 8 in my list. So this is my full list of factors of 40. Now, to find my greatest common factor, I want to look for the numbers that they have in common. I notice that they both have 1, they both have a factor of 2, they do not both have a factor of 3, but they do both have a factor of 4. 6 is not common between them. 8 is common. 12 is not, and 24 is not. Now, although all of these numbers are common factors, we are looking for the number that is the greatest. So the greatest common factor for both of these is 8. So the greatest number that they have in common as factors is 8. Now let's use prime factorization to find the greatest common factor. So I'm going to look at 20 and 28. I'm going to first make a factor tree. So I know that 20 is an even number, so it can be divided by 2, and 2 times 10 gives me 20. 20 is a prime number, so I'm going to stop there. 10 is not, so I'm going to continue going. I know that I can take 10 and I can make it into 2 and 5, because 2 times 5 gives me 10. Now both of these are prime numbers, so the prime factorization of 20 is 2 times 2 times 5. Now we'll do the same thing with 28. I know 28 is an even number, so it definitely can be divided by 2. So that prime number is going to be 2. And 2 times 14 gives me 28. 14 is not a prime number, so I need to continue further. I know that 14 is even also, so I can do 2 times 7 to get 14. Now 2 is a prime number, and 7 is also a prime number. So the prime factorization for 28 is 2 times 2 times 7. To find the greatest common factor, which is the greatest number that they have in common, I'm going to look at their prime factorization. 20 is 2 times 2 times 5. 28 is 2 times 2 times 7. The greatest common factor is going to be what they have in common. Well, I noticed that they both have a 2, and they both also have another 2. So they both have two 2's in common. But then 20 has a 5 and 28 has a 7. Since those are not numbers that they have in common, I'm not going to use those. But they do have two 2's in common, so their GCF is going to be 2 times 2, which gives me 4. So the GCF of 20 and 28 is 4. Now let's use the slide method to find the greatest common method or factor of 28 and 42. So I will write it like this, and then I'm going to think, what numbers can go into both 28 and 42? Well, I know they're both even numbers, so at the very least, I know that I can get 2 for both of these. If I do 28 divided by 2, I get 14. And if I do 42 divided by 2, I get 21. Now, looking at these, I know that they still have factors in common. So if I think about 14, 14 is 2 times 7, and 21 is also 3 times 7. So they have a 7 in common. If I do 14 divided by 7, I get 2. And if I do 21 divided by 7, I get 3. Now, at this point, neither 2 nor 3 have any factors in common because they are both prime numbers. So I can stop here. And if you remember when I did the LCM, I used this whole thing to find the LCM. But with GCF, we are actually only going to use these numbers on the outside. So the numbers that we divided by. And I'm going to take these two, which is 2 and 7, and multiply. That means that the GCF is 2 times 7, or 14. Now let's look at a problem. Joanne is campaigning for class president. She has made 20 buttons and 16 flyers. She wants to distribute the items so that each class receives the same amount. What is the largest number of classrooms that she can distribute the materials to? Because I know that she is trying to put the same amount in each classroom, I need to figure out how many buttons and how many flyers she should put in each classroom. So I'm going to find 20 and 16, and I'll use the slide method. They're both even numbers, so I know that 2 will go into both of them. And 2 times 10 gives me 20, and 2 times 8 gives me 16. Now, neither of these are prime numbers, so I need to go further. And I know that both of these are even numbers again, so I can divide by 2 again. 10 divided by 2 will give me 5, and 8 divided by 2 will give me 4. Well, at this point, 5 is a prime number, which means it is not going to share any factors with 4. So I'm going to look at my numbers that I have on my outside, which are 2 and 2. And to find my GCF, I'm going to multiply those together. So I'm going to do 2 times 2, which gives me 4. That means that Joanne can distribute her buttons and flyers to 4 classrooms.